Hi there, calculus fans. I'm going to make a video on how to integrate secant cubed. I just made a video about how to integrate secant. So watch that video. I gave some history. I gave the technique that I like to use. I looked up some history, so I learned a lot about this that I didn't know. I did look up secant cubed. Just a second here. I looked up secant cubed, and the history is kind of less interesting, but let's pull up the Wikipedia anyways. Let's hide this. So, integral of secant cubed. It said here somewhere. Derivation. Anyways, it's mostly an integral that's just kind of known to be challenging in calculus because it kind of depends on the secant integral, and that's challenging. I thought this was interesting that there's a name for this function, log of secant of x, the Gudermanian function. I've never heard of that before, but I thought that was kind of interesting. There's all sorts of proofs. I'm going to show you what makes the most sense to me. And also I'm going to show you a technique that, what I've liked about sort of reviewing this is that integrating secant and secant cube involves several of our techniques. So I talked about how in order to get this, we basically had to use 7-2, which was trig integrals, and 7-4, partial fractions. There are other ways, but if you just want to sort of follow a standard way, and then there was some simplification. If you take this as given and you use integration by parts, you can get secant cubed from secant. This illustrates another use of integration by parts. Sometimes we call these reduction formulas. Those of you that have taken some computer science, they're formulas that depend on the previous part and build. So if I know it for 1, then I know it for 3. And if I know it for 3, I know it for 5. So I think I might, at the end of this video, take a peek at secant to the 5th, which I haven't done ever before. So this will be new. But let's, for some reason, say we want to know secant cube. So the idea is to try to reduce it down. This is not an obvious thing to try, but this might give you a deeper understanding of what integration by parts can do for us. So integration by parts, we're trying to pick something so that we know how to integrate. We can take the derivative, and it makes things simpler, or in a way we can reduce it. So to me, when I look at this, you might say, well, what do I know? I don't know the integral of secant. Well, I sort of do, but it's this mess. How can I keep this row simpler, or make it simpler? And that's maybe when you come across the idea of, how about we choose secant squared here? And the reason that makes sense to me is because I know an antiderivative of secant squared. But if I take 2 of the secants, then the other one has to go here. But when I take the derivative, now this is going to be secant tangent. And at first blush, this doesn't look like it's going to make things any nicer. But it is going to it's going to change the look. So we do UV, so it's going to be secant tangent minus the integral of v to u. So I always say we smush those two together, and then we smush those two together. And the trick was to choose this, but it kind of makes sense to choose that because that's a well-known derivative. If I put those two together, I get secant tangent squared. Now, here's where some of the cleverness comes in. But at this point, it doesn't really look like it's any better, except I have an identity. And if you go back to section 7.2, we use the following identities a lot. We use the cosine squared one, the sine squared one, and then if you divide the cosine squared identity, you get this one. So I might lose you right now, but I hope not. If you're taking calculus, this is an identity we're using a lot. Or you can write it this way: we get tangent squared. And these all stem from the same identity, which is sine squared plus cosine squared is 1. If you divide everything by cosine squared, you get this. But anyways, this at first blush doesn't look like an improvement. because what am I doing? I'm making it look worse. So these types of integrals are always tough when you appear to not make progress and you have to keep going. But we're going to keep going. We're going to say secant x, tangent x, minus the integral of secant cubed x minus secant x. And here is where we realize we have it. Why do we have it? Well, because this was the starting integral. And this right here is the same thing. And if you did my never-ending integration by parts, we've seen this before. So we're going to add this back to the other side. And that's going to give us 2 secant cubed. And on the other side, we're going to have the integral of secant. So let's really break that down. So we have the integral of secant cubed of x dx equals secant x. I'll take an extra step to really help you see this. Minus the integral of secant cubed of x dx plus, it's plus because of the minus the integral of secant of x dx. Okay, so here's what we're going to do. We are going to add this to the side, and we're going to get 2 times the integral of secant cubed of x dx is equal to secant of x tangent of x plus the integral of secant of x. And now we got it. So let's zoom out a little bit. Again, if you want to know watch my other video if you want the integral of secant, but we have everything now. So let's put it all together. The integral of secant cubed of x is going to be 1/2 secant of x times tangent of x plus 1/2 of this. 1/2 of the log of secant of x plus tangent of x plus 1/2 c, but we could define c to be whatever number that is. Done. So that's the idea of reducing this integral. So sort of the key fact is this. Hope that's sort of interesting. Another use of integration by parts. Now I said before I finished the video I would try secant to the 5th. Let's try. I've never done it before. This is on the video. I'm sure I'm going to mess it up. But let's try. I'd like to figure out secant to the 5th of x. I would like to reduce it down. And now I know secant cubed, and I know secant. So let's see what we can do. What can I say? So I feel like I would like to put secant squared here again. Let's try this same strategy. And that would mean this has to be secant cubed. Okay, that means this is tangent of x. But this derivative is going to be a little worse. We're going to have to do the chain rule. So it's going to be 3 secant squared of x. And then the derivative of secant is secant tangent. Oh boy. Let's go a little further. We'll find out, and then if it isn't working, I'll bail out. But I just wanted to see. Okay, so now we're going to do integration by parts. We're going to smush those two things together. So it's going to be secant cubed. I'm sure this has been done, so we're not proving anything new. I bet there's a general formula for how to go from 3 to 5 and 5 to 7 and 7 to 9. I doubt people have needed these integrals very often, but it's kind of a fun little exercise. And then let's put these two together, minus the integral, and there's going to be a 3. There's going to be a secant cubed, and there's going to be a tangent squared. Sorry if I squished those together, but there's the tangent squared, there's the secant cubed. Okay, I think the same thing's going to work. I had a good hunch that the same thing would work because what we did looked like it's going to work past this. So this is going to be secant square root of x minus 1. In fact, now I feel like I could prove a more general result. But let's summarize everything in one spot. This is how math works. We sort of see something, and then we say, can we prove it for the next one? And then we say, can we prove it for all of them? And then we say, can we ask another question that answers even more things? That's the allure, at least was one of the allures of mathematics for me. So if I expand this out, this is going to be secant to the 5th minus 3. And I'm not showing every step. Apologies here, but this is the extra add-on I was doing. And there I see it. Except this time when I move this over, it's going to have a 3 in front of it. So it's going to be 4, the integral of secant to the 5th dx equals, and I've never seen this integral before in my life. This is all fresh on the video. This is going to be plus 3. So I moved this integral over to the other side. Secant cubed of x dx. Well, that's interesting. We know what secant cubed is. Wow. Should I write this out in all its glory? I better. It's the first time I've ever done this. So the integral of secant to the 5th of x dx is 1/4. Maybe I'll write it this way just so we can, I won't distribute it, clean it up. Secant cubed tangent of x plus 3 times our previous answer. So there's going to be a 3/2. Maybe I'll write it this way. Secant of x tangent of x plus log, whatever that was, the Guggenheimian function. All right, plus c. I know I didn't. I didn't say it right. That's it. So that makes me wonder if I want to do the 7th. I'll leave that for the viewer. What if you wanted secant to the 7th? And my conjecture now is that secant to the 7th of x dx is probably going to start with a 1. Let's see, I'm going to take 2 out. Probably a 1/6. I'm just trying to think of how these numbers are going to change. And then I think there's going to be a secant to the 5th x tangent of x. And then I'm just trying to think through what would be here. Plus, there was a 3 there. 1/6 of this. Plus, we're going to have this number out in front, which is going to be a 5. Plus 5/4 times all of this. That's my conjecture. Anyways, so then you would try to prove something about how you get one from the next. And so this would end, if you wanted to give a, write a book with every secant integral, you would have something that would say secant of n plus 2, where n is odd, maybe you would say, is 1 over n plus 1 secant to the n tangent of x plus, what would this be? This is my conjecture. I'm doing it on the fly. If it's wrong, please tell me in the comments. And I'm sure it can be looked up, but this is more about the ideas. So let's see, so this is going to be n, maybe over n minus 1, the integral of secant of n. And I have no idea. I think I was just spitballing there. Okay, so I hope that's interesting. This is more about integration by parts than anything else. But there you go. So secant cubed is mostly challenging because if you're starting from scratch and have nothing else, it's going to be hard to handle. But if you already have secant, then secant cubed can be done with integration by parts. All right, I hope that's interesting.